We, as always, will always begin with copying the given information. So if we know that QT bisects angle PTR, and we know that QT is perpendicular to PR. So those are the given pieces of information. And in all the proofs that we've done so far, I usually encourage your first steps to be introduce the elements of your end state. So if your end state has angle 1 plus angle 2 equals whatever, I generally encourage you to introduce those elements into your proof. In this case, your final statement is a congruence statement. So what that means is you need to, in order to prove these triangles congruent, you need to fulfill one of the 4 patterns. And remember, SSS, SAS, AAS, or ASA. So instead of actually introducing the elements as the triangle itself, you need to introduce the elements as the sides or angles that can correspond and be set equal. Right? So in order to do that, with these kind of proofs, you're generally just going to build from what's given. So let's take a look at what's given if we label this. So we're told that QT bisects angle PTR. So that means that these 2 angles are going to be equal. And then it also says that QT is perpendicular to PR. So we know that this is a right angle here and here. Okay, so there's the information that we can interpret. We do need to actually write these out as steps in our proof to further identify. So if we wanted to say that these 2 angles are equal, we need to make that statement. So we could say that angle PTQ is equal to the measure of angle RTQ. And what allows us to justify that statement? We use the fact that it was said to be a bisector. So definition of bisect is what you can use to justify that. And now this gives us one corresponding set of information that is congruent. Okay, so what I'm going to do is I'm just going to label that outside the proof. I have one pair of angles that are congruent. Okay. We now know there needs to be 2 more pieces of information that are congruent in order to show congruence of triangles. And well, I also see right here, based on these labeling, what do we know about angles 1 and 2? They're congruent also, right? They're both right angles. In order to make that statement, it is going to take 2 steps. You have 2 different ways to approach that. One way is you could simply say that angles 1 and 2 are right angles. And you know that these are right angles because it's said that QT and PR are what? Definition of perpendicular. So by definition of perpendicular, we could say that these angles are right angles. And then what do we know about all right angles? Angles 1 and 2 are equal because of the postulate. All right angles are equal. Right? So this was one of the original postulates that we identified in chapter 3. Okay, so this gives us now another set of elements that are equal to each other. Okay, and so now we need to look to see what pattern are we building toward. We have 2 angles. We need another side. It doesn't matter where the sides are, because we could either use AAS or ASA. Is there any pair of sides in this triangle that we could state are equal in the 2 smaller triangles, PQT and RQT? QT, right? QT is equal to itself. So that would be our next statement, is that QT is equal to QT. Okay. We had talked about this statement earlier, and I said we'll use it in more detail, especially when we get to this particular chapter or later chapter. This is where that takes place. What justifies something being equal to itself? Just remember what that was called? Reflexive property. Okay, so by reflexive property, we know that QT and QT are equal, so this gives us a pair of sides. So we have 3 pieces of information. Now disregard the order that they go in, because we could have moved step 5 anywhere along the way. So the order that you see these letters in this vertical arrangement doesn't give you the pattern. And what you need to do is look at the figure. We have two angles and a side. Is that enough to show congruence of triangles here? Yeah, and which patterns fulfilled? Is the side included between the two angles or opposite one of the angles? It's between them. So our final step is to justify triangle PQT is congruent to triangle RQT, and the pattern is two angles and the included side. So ASA is that pattern. Okay, now there's two things that I want to discuss here. The first is there's an alternate set of justifications for step 2 and 3. Okay? Instead of saying that, or I'm sorry, 3 and 4. All right, so the alternate for statements 3 and 4 are, instead of saying that they're right angles and then that all right angles are equal, we could have begun right away by stating what the actual angle measure is. So if you'd rather work in measures, in step 3, you could have justified, or you could have made the statement that angle 1 is equal to 90 degrees, angle 2 is equal to 90 degrees. The reason would still be definition of perpendicular, because that's what it says. It meets at right angles, or again, if you're using magnitudes, it meets at 90 degrees. If you chose to use this as your statement in step 3, the statement in step 4 is now going to be the same. You would still say angle 1 and angle 2 are equal. But now the justification is different, because we don't specifically have that they're right angles here. We actually have their measures. So we're dealing with the equation properties. And so what property, algebraic property, allows you to move from statement 3 into this new statement 4? Two things equal to the same thing or equal to each other is transitive. Okay, so if you decided to use this instead, your steps 3 and 4 would still have the same end result. Angle 1 and 2 are equal, but it would go about it in a slightly different way. Okay, so this is how you would complete this proof. I want to take a hypothetical. Let's say instead of asking you to prove that the triangles are congruent, let's say they ask you to prove that PT is congruent to RT. All right, if you're asked to prove that pieces of two triangles are congruent to each other, so can we show that PT and TR are equal? What you would have to do is go through the whole process that we did here, show that the triangles are congruent, and once we have this congruent statement in step 6, we know that there's all 6 relationships between corresponding pieces are equal. So all corresponding angles are equal, all corresponding sides are equal. And so if we now could move, if that was what we were asked to do, we could specifically say PT, which is the first and the last pieces on this congruent statement, are equal to RT. It fits with that congruent statement. And so there's 2 possible ways to justify this. The first, and probably the easiest to think about, is we simply interpreted congruence. So by definition of congruence, congruence means equal in all respects. So it would make sense that these corresponding pieces would be equal. It's one of the statements that you can derive from the original congruent statement. The other way that you can justify definition of congruence is use that use the abbreviation CPCTC. And what CPCTC means is corresponding parts of congruent triangles are congruent. Okay, so C, P, C, T, C. I don't care which one you use if you're asked to do this on your own, but you need to be able to identify either one, because most of the proofs that you're going to see are going to be in a drop-down menu type thing where you choose the correct reason. I'll never have both. You never have to choose one or the other, but you will, maybe in one problem you'll see definition of congruence. In another problem dealing with the same thing, you might see CPCTC. You need to know what they mean and that they are referring to the same thing.